This is the 1978 motorhome that I'm rebuilding, and the problem that I want to fix today has to do with the rear view mirrors that are manually adjusted. You can see that these are a little bit awkward to adjust, and my wife and I are different heights, so these are going to be needing to be adjusted all the time, which means that power mirrors would be a really nice thing to have. Thankfully, there's a cult following for these GMC motorhomes, probably because they are the best motorhome ever made. So that has kept Applied GMC in business all these years. And here they have a set of these mirrors which are powered and heated. So if I was sane, I would just buy these for $800, $728. But that just seems kind of expensive to me. So I went looking on eBay and I found these mirrors for $166, which are also heated and powered. And they have a turn signal, same deal. Everything that I'm looking for, a whole lot less money, and I just need to adapt them to work on the motorhome. We can see what the stock mirror mount looks like, and it doesn't stick off the motorhome very far. I've removed the mirror here on the passenger side, and we can see that the mounting pattern is just these 4 bolts, and I'll probably have to replace the acorn nuts that go on the studs, just because those are kind of rusty. But I would like to maintain this bolt pattern. And we can see that's going to be a little bit of a problem because look at the length of those arms, and the motorhome's already really wide. So we need to basically just take that mirror head and mount it onto that bracket. Unfortunately, that's not really going to be an option because you can see the mount here is about 1 inch in diameter, and that nut and bolt is much smaller. Also, the height on the bracket from the bolts to the top there would put this much larger mirror in an awkward position. Also, this is a threaded post, whereas this needs to be pinched, some sort of a clamp, in order to work. We pretty much need to make a whole new bracket, and I don't have a metal fabrication shop set up here in my garage, so that leaves me to rely on 3D printing. So let's see what we can make with plastic that will be strong enough and do the job. In order to design this geometry, I started off with the 4 stud holes drawn to scale, and also that box at the top there is the plane where the mirror will mount. So using those 2 references, I then just started playing with shapes to see what would be best to bridge those 2 critical planes. And you can see this is the shape that I ended up with. It's kind of stronger in one axis. That's the axis the wind's going to be blowing against it. And yeah, that's what the part's going to look like when we're all said and done after we're done printing. It won't be quite as smooth, but you can see just how seamless and organic this shape is. So the question now is which filament to use. Now the number 1 consideration for this project is I don't want it to cost very much money, which means that an exotic filament like carbon fiber impregnated polycarbonate, yeah, that one's out. And that leaves me with the 3 most common filament types: ABS, PLA, or PETG, otherwise known as copolyester. So ABS tends to warp when you print larger pieces, which is what I'm doing right now. So we're going to remove ABS from the list. Also, it stinks a lot when you print with it. So that leaves us with PLA and PETG. So let's move on to the next criteria, and that would be strength. So FDM printed parts are weakest in the Z direction. They tend to delaminate along layer lines. So our layer adhesion is the number 1 consideration for strength. And according to Stefan and his fantastic videos there at CNC Kitchen, both PLA and PETG achieve similar layer adhesion. With PLA, you have to print at a higher temperature than you think you should, and with PETG you need to print without a cooling fan, and then they're both equally strong in the Z direction. So those are equals there. So let's move on to the next criteria, and that would be longevity. Now PLA will biodegrade under the right conditions, like in an industrial compost heap, basically. PETG is like a 10,000 years in the landfill kind of material, so not going to biodegrade, but it will degrade in the sun. It is UV sensitive. So either one of these I'm going to have to paint. The PETG I could leave in its raw 3D printed form with the layer lines showing and just spray paint it with some clear coat, and it would work just fine. With the PLA, yeah, I guess I could clear coat it, but probably what I'm going to do is spray it with some high build primer, which will fill in the layer lines sand it smooth, and then put a nice glossy coat on it so you won't even be able to tell that it was 3D printed. So the question is, do I want an honest 3D printed part which shows off the fact that it was 3D printed, or do I want the polished looking part that you'll never know? And I think you guys can tell I'm going to go for the polished part made from this PLA. You might have noticed that the brand here of filament that I'm using is Filamentum. Normally, I just use bottom of the barrel crappy stuff from China, but in my test prints so far, this stuff is performing pretty nicely. And you know, it came in this bag, which is resealable. So basically a Ziploc bag, which includes the desiccant packs. And that's just a nice little attention to detail that shows that this company coming out of the Czech Republic cares about quality. And there it is, 16 hours later, the finished print. Let's get this cleaned up and take a look. Design prototype test, right? So I'm test fitting this part and it's revealed a couple of problems. First of all, the studs from the factory are not perfectly regular. So these holes here are too tight of tolerance. I made them to accommodate the socket like so, and because the acorn nuts are sitting off center there, the socket can't slide over them. I had to tighten that down with a needle nose pliers, so that won't do. I'm gonna have to give myself a little bit more wiggle there. And then the other major problem here is I got the angle wrong. You can see that the mirror is leaned quite a bit to the inside, so I need to straighten that up, and because it's leaned so far to the inside, I'm colliding with the windshield right there as I try to turn it. But the height is good, and I really like the way it looks. So we'll try this again, and hopefully I'll get it right the second time. This whole mount definitely flexes when I move the mirror. I don't know if you guys can see that. Back there in the crack, you can see it sort of expanding and contracting a little bit as I flex that. But the body of the motorhome itself is kind of flexible. Like if I push here, I can watch the mirror move up there. So I want to see how far this will go before it breaks. Oh, now it's breaking right there. Here we go. Let's do a quick failure analysis on the part. It broke exactly where I expected it to break. Right there, starting at the corner, the inside corner, and up along the layer lines. So I need to add a fillet to that inside corner to relieve the stress there. But yeah, that's pretty much what I thought was gonna happen. What surprised me was when it originally started to break, it was happening right here, right where my fingernail is. And that's just a really bizarre place to break. In between, you can see the crack goes in between the bolt holes. Actually, this crack goes down just to the far side of that bolt hole. So that's just interesting. It's really interesting. But again, that's a failure along the layer lines. So just like we expect, the layer adhesion is the weak point of FDM printing. Meanwhile, the replacement print is coming along nicely. You can see no stringing issues like I had with the first print, and that's just because I spent the time to set this thing up correctly in the slicer software. This is the modified geometry here in Simplify 3D with the support material ready to be printed. But here we see that I have different processes ready to go, and you can see the layer here is 0.05 millimeters, and that's just my beginning, the very, very bottom of this print. And then the next setting up there is going to be 0.0833, and then eventually at the top here I'm going to work my way up to a layer height of 0.15. And here in the simulation we can see the striations, the different sections. So this bottom triangular looking part, that's the 0.05 millimeter layer height, and then the 0.083 and blah blah blah, moving on up. And here's the simulation with the support material included, and I think this is going to be a really nice print. And it does look pretty nice. We'll see how well the support material comes off. I'm gonna have to do this off camera. It's gonna take some finesse. Okay, that was no easy task. Let me tell you guys, at 0.05 millimeter layer height, support material really does not like to let go. You can see I even started to split it along the layer right there accidentally while trying to pull the support material off. I really like the way this version is looking, but it still doesn't sit off the motorhome quite far enough. You can see there's a gap there, but when I adjust the fisheye mirror, it actually still touches the windshield. So that's not good. I'm gonna have to space it off another ½ inch, which is exactly what I'm doing here in Rhinoceros 3D, the program that I used to create this geometry. So you can see what I'm doing here is cleaning up the the drill holes. These are the this is the geometry where the socket wrench will fit down into, and I'm just getting that ready to subtract with it once I draw the new organic surface on the outside of this part. And so I just copied some of the geometry that I drew previously over to this one here, and then I made two versions of it. So what I want to do here is play around with a more chunky, sort of beefy base and see how that looks. And then the one on the right is going to be sort of more true to the original design intent. So yeah, here I am subtracting with those cylinders that I was talking about a minute ago. And in a second here, I'm going to have two completed geometries that I can sort of just do a little mini design critique on. So render these things so they look like they will look in real life, and then take a close look at them. And yeah, I don't like the left one because the drill holes basically extend too far through it, and it looks weak. So I'm going to go with the one on the right that just looks true to the original intent, and I think it looks pretty elegant. So that's the one to use, and that means that I'm now going to put the finishing touches on it with the fillets. And Rhino will largely automatically generate fillets, but there are always some kind of funky issues that arise. So what you see me doing here is cleaning up the bottom portion of that fillet where it sort of like went beyond its boundaries. And that just means I need to generate a new bottom of the drill hole surface, that flat surface there, as well as sort of patch and repair the outside surface of the part. So once I've generated that bottom surface, I'm just going to sort of untrim the there you go, the untrim, and then retrim the holes out, and that's pretty much a finished part. What you're looking at right there. Now, I didn't really talk about it, but I drew previously this crescent, which is an upgraded version of the crescent on the first design, and we'll talk about that here in a second. This print turned out so good, so good. 26 hours it took to make it, and it's flawless. So let's take a closer look at this thing. The most striking thing I've noticed about this Filamentum PLA is the surface finish. It has this pearlescent quality that I've never seen before, and it just looks so good. It's a shame that I'm going to be painting over this. Design-wise, I'm pretty sure that's a winner. You can see what I've done here with the crescent is I made it so that there's no gap there at the bottom, which means that as I push up here, there's no gap to close, so it's effectively sort of like one solid piece. So it's a whole lot stiffer. I mean, it's still got flex, but it's a whole lot stiffer than it was. And yeah, so it works really well. Plus with the fillet there, basically it can follow a layer line straight across to about there on the screw. So there's a single layer from there to there pretty much, which gives it a whole lot more strength. So yeah. Like I said, I think that's a winner. But the problem is that I'm out of Filamentum PLA material. And this stuff was gorgeous, but I was going to be painting over it anyway. So I can either print with some crappy Chinesium PLA filament that I have, or I can use the good Filamentum copolyester and do very little post-processing work, which is nice. So basically I'll just be able to do that print, same print that I just did, just up the temperatures and slow it down a little. And the only thing I'll need to do is spray paint it with a UV resistant clear coat, and I'll be done with this project. And I woke up this morning to this mess. Obviously the print failed, and that's 8 hours of printing, just to give you an idea of how slowly this is printing. I don't really understand why it's failing to print. This is PETG. We're not supposed to have any real shrinkage issues. Anyway, this is the second time this has happened. The first time it happened, I turned that into a test print for the spray paint. So it's actually, the spray paint's the clear coat's gonna look really nice. But I just gotta figure this out. Now I've got it printing just about perfectly. Turns out that the problem was wet filament. So I stuck it in my filament dryer overnight and started printing this morning, and it's absolutely perfect. Which means that this CPE, this copolyester filament coming from Filamentum, is more moisture sensitive than the typical PETG that I'm used to working with. And I read up on the internet, and apparently there's just a huge variation in the properties between the different polyester filaments. So yeah, take it as it comes with your copolyester or PETG. It can be very different from one filament brand to another. So even though I'm going to say drying the filament was the principal solution here that's causing me to get a really good print, I'm not going to let this printer off the hook just yet. This printer uses this inductive proximity probe, and these things are really cheap, like $3, but they're junk, and it's just a terrible technique to use. You know, getting it to work with this table and trying to adjust for temperatures, and it's just patches on patches. It's no good. So I'm gonna go with the solution that is good, and that is the BL Touch sensor. So I'm gonna modify this printer with the Duet Maestro to work with the BL Touch. And then I'll be able to trust that my bed is actually leveled because I wasn't getting good bed adhesion. So as the dribbly wet filament was being pushed out of the nozzle after a retraction, it was then moving across those bits of support material, and the wet filament ooze was catching the support material and knocking it over. And so the bed wasn't adhering quite as well as it could have, and so that's why things were just breaking off. So mostly caused by wet filament, but also caused by this probe. So yeah, now that I've got that solved and it's printing nicely, I just have to wait about 3.5 days for this to finish printing. I've two of these to print, and also 2 of the little crescent pieces, and then I can install that on the motorhome and I will be finished. I have the final PETG or CPE print ready. It's all printed, ready to install. So it's going to replace this PLA print here, but these are the same geometry. So that means that they both have that extremely large fillet that you can see there, which should have strengthened things up quite a bit. So I want to give this one a brake test just like we did to the other one. So let's see how much force it takes to brake this thing using my finely calibrated hands. Should be a good accurate measurement device, don't you think? Theoretically, we'd be driving down the road and we'd hit something and it would push the mirror that way. So this is exactly the direction, and I'm going to push it basically straight along the side of the motorhome here. Wow, I'm really pushing. Holy crap balls. That is way stronger than I thought it was going to be. Okay, so let's try it the other way. Let me grab that mirror that way, and we're going to try to break it in towards the motorhome. Okay, well, I mean, I could push harder, but I'm afraid I'm going to damage the mirror housing, or maybe hit the window after I hit it that hard. Okay, like this is pretty good results. And this is the PLA. This isn't even the CPE, which should be a little bit stronger. I don't think I can break that. So that's some pretty good result right there. Pretty happy with that. Actually, I bet I can break it if I pull it towards me. I don't see that ever really likely happening, but let's just make it happen. Okay, maybe not. I'm not gonna go anymore. I'm afraid I'm gonna break the motorhome or the big mirror portion. I am quite happy with that. So I'll give you guys a little before and after shot, and all I have left to do now is to wire up the power mirrors so that I can control them from inside the cab. And that'll do it for this video. Thanks for watching. See you next time.